Hey guys, okay, so today we're going to talk about exactly how a nuclear power plant works. So, what I want you to do is if you have headphones, you can put them in and you can listen to this video as we go through it. There's not going to be anything for you to type specifically, so I want you to just be sure that you are listening close. Okay, so this is our nuclear power plant. We've got control rods that we talked about last week that you can lower and raise depending on how fast you want the reaction to go. And then its purpose is to heat this water that's in this pump. So we got one loop here. The fission reactions are going on here, they're heating it. Then you've got steam generator. That's some cooler water that once it goes through this pipe of hot water, it starts to get warm and it starts to create steam out of that water. And so the steam comes through this line and it gets to this thing that spins. And because it's hot water and it's steam and it's moving, it spins this turbine. If the turbine didn't spin, the generator wouldn't work. So the turbine has to spin. All right, so the turbine spins, and that's what gives the generator power. Just like you have a hand crank flashlight, if you don't crank that, you don't get the actual light in the flashlight. If this steam was not here to turn this turbine, the generator would not work. So the generator works, it pushes the electricity out through the lines, the power lines, and then the rest of the water is just pulled down here and recycled. And then you've got this cool water right here that goes to the big towers, and all those do is they cool the water and release it into a reservoir so that it can be recycled. So everything kind of stays within the power plant. Now, energy is produced at a controlled constant rate. You don't want to get out of control. They use the control rods to control it. The nuclear fuel, uranium-35, is like this little eraser-sized pellet. It's what's in the fuel rods that keep the fuel from escaping. It allows neutrons to pass through it. So one little eraser-sized pellet of uranium is equal to a ton of coal. 1 ton. Okay, so it's a lot more efficient. These are what little rods look like. All right, so I want you to pause this video and click here to watch this YouTube video. Okay, so it says control rods often made of cadmium. They absorb some of the neutrons and they're raised and lowered in order to increase or decrease the concentration. So what I want you to do is I want you to click on the video and watch it if you haven't already. They have padding and cooling that absorbs the heat and the heat energy that's released. And then outside the reactor, the coolant is used to heat the water and produce steam. Steam is what spins the turbine. If you didn't have that steam, it would not be able to turn that turbine. All right, so when we talk about our problems in the U.S. with nuclear energy, one of the big ones is 3 Mile Island. So I want you to stop, play this video, and watch the chaos at 3 Mile Island. So some scientists argue that nuclear power is the safest way to make reliable electricity. It's got very little pollution, and it's caused very little deaths over the past 50 years. Even if there is nuclear power, even if it's the safest, there have been some major accidents. So in 1979, there was this accident at 3 Mile Island in Pennsylvania. It was a partial meltdown, not a full one, and the government went into action to prevent casualties, and cleanup took a really long time, like several years. So go ahead and play this and watch the video. All right, so when we're talking about Chernobyl, this is a lot more of a serious issue. Several systems failed and the nuclear reaction became uncontrolled. 2 plant workers died immediately. Several people died within days, and some took months to years. They died of cancer from all the exposure to radiation. In Fukushima, this was back more recent, 2011, there was an earthquake, and the generators that controlled the coolant pumps shut down. So what happened was ocean water flooded some of the areas of the power plant, and the isotopes, the radiation, entered the ocean and nearby groundwater and soil. So basically the radiation was all in their soil, and they're still trying to clean that up. So we're going to look at the benefits and also the cons, the pros and the cons. So the benefits, there's no pollution. Be sure you pause and watch this video. It's a very low cost. And it produces a large amount of energy. About 5 uranium pellets produces enough household electricity for a year. So 5 little tiny pellets would keep your house powered for a year. and it's almost inexhaustible. What that means is they can be manipulated by scientists. We can keep having them readily available. Another benefit is that it's far less dangerous as compared to like coal, oil, and natural gas. It can be used to find leaks or weak spots in pipes. It can be used in tracers and to destroy unhealthy cells. Can kill bacteria, causing food to spoil. So nuclear energy is used in a lot of different ways. So some of the issues. Be sure you play this first. This video, play it first. So most experts agree that nuclear energy should be buried hundreds or thousands of meters underground. Well, that's kind of hard to do with all this stuff. So the waste is really radioactive and we haven't really found a good way to store it. Nuclear weapons. Thankfully, most of the countries have successfully signed these nuclear non-proliferation treaties. All that does is allow the countries to have nuclear weapons. So China, France, Russia, the UK, and the US all have nuclear weapons. So this can be a positive, but it also can be a negative because if those countries have it and they aren't happy with you, we already talked about what that can mean. And nuclear accidents. There are potential harms to many people that live in the area with a nuclear power plant if there was to be an accident. Okay, so that is all I want you to do for today. I do want you to look at this though, and if you have time, go ahead and play this video. And while you're looking at it, look at these questions right here. All right? Have a great day. I'll see you soon.